We know it as the B-2, but its full name is the Northrop Grumman B-2 Spirit. It's one of the most powerful aircraft that any country's military defense has. But what makes it any different from any other aircraft? Its role is to be a stealth bomber. So it should come as no surprise that stealth is its #1 priority. But how can an aircraft that travels at a top speed of Mach 0.95, almost the speed of sound, stay hidden so well? Join us in this video as we explore the unrivaled power of the B-2 bomber. It's wider than it is long. Its 52-meter wingspan trumps its 21-meter length, but remains virtually undetected. This is all thanks to its clever packaging. A radar cross-section is how detectable something is by radar, and the B-2's cross-section is just 0.1 meters square. Compared with a cargo aircraft, which can measure anywhere up to 100 meters square, this low-drag wing configuration not only helps it achieve minimal cross-section, but its range is also vastly improved. It can travel more than 11,000 kilometers, about 6,900 miles, in one go, and can keep going thanks to its ability to be refueled mid-flight. Radar-absorbent materials like a carbon graphite composite help reduce its infrared signature by absorbing many of the radar beams that would normally detect such a plane. In fact, up to 80% of the aircraft is made of composite materials which, as well as having radar-absorbent properties, are extremely strong and well-suited to the B-2's ultra-dynamic nature. The wings, for example, have a larger degree of flex than aeroplanes you and I may have flown on, which helps absorb energy from aerodynamic stress, making it more efficient at high speed. Using these materials also helps the longevity of this bomber aircraft. While metals and metal alloys have a shorter lifespan, composite materials can be meticulously engineered at a molecular level to extend and improve what is known as fatigue cycles. A growing number of target countries are recognizing this though, so have turned to other ways of detecting an aircraft. Infrared systems are used to detect the heat of an aircraft, not only from its engines, but the body which heats up due to air friction. The engines are buried deep in the fuselage to help combat this. To keep the aircraft as prepared as possible in the event of a technical mishap, the B-2 was additionally built not to rely on GPS, but rather a range of sensors, gyroscopes and radars to help pilots recognize where they were based on landmarks. A GPS antenna would also make it more susceptible to being picked up by enemies. Hundreds of thousands of dollars were later driven into developing a new type of GPS, known as M-code, which are more reliable, responsive, and destined only for use by the military. This represents a significant milestone in navigation technology. It may be a powerful aircraft, but it doesn't just need to be stealthy. Its primary purpose is to carry and fire ammunition in target countries. With a width that is half the length of a football field, you may think it can carry a lot. Double this and add some more. That's how much the B-2 can store. 2 internal bays have an official limit of 18 tons, but it's likely that it could carry even more if needed. Its armament includes 80 500-pound class bombs, 36 750-pound class bombs, 16 2,000-pound class bombs, and 16 nuclear bombs, such as the B-61 or B-83, as well as a handful of other satellite-driven missiles and penetrators. An update in June 2007, a decade after it was first conceived, the B-2 was awarded a contract to integrate 2 massive Ordnance Penetrator, or MOP, weapons. This GPS-guided weapon carries 5,300 pounds of explosive material and is designed to target even the most protected enemy compounds. Its manufacturers say that this is the most survivable aircraft in the world and combines 3 things that no other rival could: long range, stealth, and the ability to carry an extraordinarily heavy payload. All of this comes at a cost though. Each supposedly game-changing aircraft cost $737 million in 1997. That's about $1.2 billion adjusted for today's currency. This is affordable though compared to the cost incurred to develop the B-2, including testing and deployment. The figure is placed at $2.13 billion per aircraft for this, around $3.5 billion in today's money. Initially, 132 examples were commissioned, but this was later dropped to 75. After the Soviet Union had dissolved in the 1990s, only 20 were acquired, as set out under the George H.W. Bush administration, although a final 21st aircraft was given the go-ahead to be converted from a prototype. All 21 examples are still in operation, and the US plans to keep them until 2032, retiring them at an age of over 30 years old. Some of the cost went into acquiring an old Ford plant in Pico Rivera, California, which had to be rebuilt to be able to house the aircraft's extensive wingspan. The early stages of the program were kept so undercover that the staff would often be required to work out of uniform to avoid suspicion, and would even be subject to routine polygraph or lie detector tests. Much of the company's procurement would be placed through front companies so that the assembly of the B-2 would be kept secret. Purchasing them is one thing. Keeping on top of the world's most impressive stealth bomber is another. It's estimated that each hour of flight requires 119 hours in maintenance. That's twice what is required by the B-1B and B-52. In 2010, it was said that each hour of flight cost $135,000 to the US taxpayer. We've covered every aspect of the B-2, from its impressive stealth to its staggering firepower, but what's it like to be inside one? Pilots are trained daily, which means they are able to competently fly the aircraft whenever a mission requires them to. The trainee and the instructor occupy the aircraft's 2 seats, both of which have access to the stick. With hands-on at all times, the instructor can intercept at any point. Protocol says that the person who takes over should say, "I have the aircraft," which is met with the other person saying, "Roger, you have the aircraft." Like most commercial aircraft, this too has autopilot, which is used to keep things on track like its altitude. Space inside is limited to the 2 seats and a narrow passage behind them, which provides just enough space for a blow-up mattress. There is no bedroom or fridge. The duo are expected to carry non-perishable food items. And despite the ultra-high-tech cockpit, the toilet is, less so, to put it politely. It comprises a stainless steel bowl in the space behind the seats, completely uncovered. As if flying such a large aircraft isn't enough, pilots should be aware of both air attacks and more secretive digital attacks, as well as preparing weapons and keeping tabs on information like hydraulics, electronics, and environmental conditions on the 8 screens that make up the majority of the cockpit. We're told that the biggest challenge is managing all of this at the same time, in an aircraft that's traveling at almost the speed of sound. Whether you agree with military activity or not, there's no denying that the B-2 bomber is a ridiculously advanced, high-tech piece of engineering that combines some astonishing facts. A high top speed and the power to destroy whole areas, all while maintaining ultimate stealth.